Today we are doing lesson 16.7, operations in scientific notation. Our I can statement for today: I can add, subtract, multiply, and divide numbers written in scientific notation. So for our first type of problem here, looking at addition and subtraction. So for our rules for addition and subtraction, before numbers in scientific notation can be added or subtracted, the exponents must be equal. That's kind of like when you're adding or subtracting with decimals and you have to line up the decimal places. In order for our place value places to be lined up, both of our exponents have to be the same. So for example, here we have 10 to the second power and 10 to the third power, and it's not equal. So you have to adjust one of them, and it doesn't really matter which one you do. I usually change the smaller one to be the bigger one, but you could go either way. When your exponent gets bigger, so 10 to the second becomes 10 to the third, our first number gets smaller. So instead of 3.4 times 10 to the second power, we added one here and made this smaller. Okay, so you kind of think of it as balancing out. We made this smaller to make this bigger. Once the exponents are the same, then we can add the numbers on the front. So for this one, you would add 34 hundredths plus 4 and 57 hundredths, and that gives us 4 and 91 hundredths. And of course, on all of our problems today, our very last step will be, is our answer in scientific notation? And if we, when we add or subtract, have something that is not between 1 and 10 as our first number, then we will have to adjust that exponent so that the first number is between 1 and 10. All right, so let's go ahead and take a look at these problems. All right, find the sum or difference. Write your answer in scientific notation. Okay, I'm going to write them out this way. 4.6 times 10 to the third plus 8.72, I'm going to line up my decimal, times 10 to the third equals, all right. My 10 to the thirds are the same. Great. So I'm going to make it times 10 to the third. 10 to the third means 1,000. These numbers are in the thousands, 4,000, 8,000. These are the same. It tells me the place value for these first numbers. Okay, I need a placeholder 0. And we're not using calculators today to do our calculating. Okay, 0 plus 2 is 2. 6 plus 7 is 13. We bring down our decimal place. We carry the 1. 1 plus 4 is 5, plus 8 is 13. Then as our last step, we think, is our number in scientific notation? So 13.32 times 10 to the third power. Well, no, that's not scientific notation because our first number is too big. It's not between 1 and 10. So I've got to move my decimal one place over. For every place that we move our decimal in either direction, that's going to make our exponent either bigger by 1 or smaller by 1. And it's always the opposite of what you do to the first number. So here we made our first number smaller. It was 13, now it's 1. When our first number gets smaller, our exponent gets bigger. We've basically divided this first number by 10 and then added a power of 10 to it. So this is our final answer. All right, so for B, we have 3 and 5 tenths times 10 to the negative second minus 6 and 6 tenths times 10 to the negative third. My exponents aren't equal here. So in order to operate with these numbers, I need to make them the same. So I'm generally take my smaller one and make it bigger. You can go either way. These are negatives. So negative 3 is the smaller value. I'm going to make it bigger by making it 10 to the negative second. If my exponent is getting bigger, my first number is getting smaller. I needed to move it one number here, one number bigger, so I'm moving one decimal place to making this number smaller. Okay, now I have the same exponents, which means I'm ready to write my problem. Okay, so I've got 3.5 times 10 to the negative second minus 66/100 times 10 to the negative second. All right. 10 to the negative second. That stays the same. That's just telling us the place value of our numbers. Okay, so now over here I need to add a decimal. Sorry, add a placeholder 0, so I have the same amount of decimals. 0 minus 6 takes me into the negative, so I've got to borrow from the 5. That's going to be a 4. It's going to make this 0 a 10. 10 minus 6 is 4. 4 minus 6 takes me to the negative, so I've got to borrow on this one too. This becomes a 2. This becomes a 14. 14 minus 6 is 8. And my decimal, I'm bringing the decimal straight down. 2 minus 0 is 2. 2 and 84/100 times 10 to the negative second. My last step is to think, is my answer in scientific notation? All right, first number, is it between 1 and 10? Yeah, it is. And it's multiplied by a power of 10, so this is scientific notation. All right, go ahead and pause the video and try these two on your own. All right, let's go ahead and check our answers. Find the sum or difference. Write your answer in scientific notation. So here for the first one, I have 8 2/10 times 10 to the negative second plus 3 41/100 times 10 to the negative first. My exponents are not the same. That means my place values are not going to line up correctly. So in order to change that, I'm going to make them the same. I'm going to take my smaller one and make it match my bigger one. So 10 to the second power. I need to move my decimal 3 places. -1 to 0 would be 1 unit, and then up to 2 would be 3 units. 2 minus that -1 is 3. So that means I'm moving my decimal 3 places, and since my exponent's getting bigger, my first number is getting smaller. So I'm going to move it 1, 2, 3 places over. Okay, that's going to make this first number 0.00341. Okay, now I have my numbers so that my exponents are the same. So now I'm going to write them off to the side here. 8 2/10. I know I'm going to need some placeholder zeros, so I'm going to put the times 10 to the second power way off to the side. Plus 0.00341 times 10 to the second. All right. My 10 to the seconds are the same, which means this is lined up correctly. My answer is going to be times 10 to the second power. This stays the same. All right, now I need some placeholder zeros here, so I have all of my zeros lined up with my numbers below it. Okay, 0 plus 1 is 1. 0 plus 4 is 4. 0 plus 3 is 3. 2 plus 0 is 2. Oh, wait, hold on. 1, 2, oh, this is 0 plus 0. My decimals got a little crooked there. 2 plus 0 is 0. Oh, my goodness. 2 plus 0 is 2. Bring down the decimal. 8 plus 0 is 8. Whew. Okay. We're not going to round our answer unless they tell us to round. They didn't tell us to round, so we're going to leave it this way. All right. Is it scientific notation? Well, yes. My first number is between 1 and 10. And it's being multiplied by a power of 10. So this is my answer right here. 8.20341 times 10 to the second power. Let's take a look at our next one. 7 8/10 times 10 to the negative fifth minus 4 5/10 times 10 to the negative fifth. Lucky us, our exponents already are the same, so we don't have to adjust anything before we start our problem. 7 and 8/10 times 10 to the negative fifth. This one's subtraction. 4 and 5/10 times 10 to the negative fifth. All right. Our exponents here are the same. It's going to stay the same. 10 to the negative fifth. Over here now I'm ready to do my subtraction. 8 minus 5 is 3. Bring that decimal straight down. 7 minus 4 is 3. Then I look to see, is my answer scientific notation? 3 and 3/10 times 10 to the negative fifth. My first number is between 1 and 10. My second number is a power of 10. So yes, this is scientific notation. All right, let's take a look at multiplication. The rules for multiplication are a little bit different. So when the numbers in scientific notation are multiplied, only the number is multiplied. The exponents are added. So you can think about this as kind of like a distributive property problem. We have to multiply these parts together. We have to multiply these parts together. And when we multiply with exponents that have the same base, the exponents get added. Okay, so it's kind of like distributive property or even commutative property, really. We're taking our order of our multiplication, we're flip-flopping it so that we're multiplying the initial numbers and multiplying the exponents. And when we multiply with the exponents, we're really adding the numbers for the exponents. Just like when we multiply with decimals, we don't need to have our decimal places lined up to do that. We can just count the number of decimals in our problem and make sure it's the same in our answer. Same thing here, we don't have to line up those exponents the way we do in addition and subtraction. It doesn't matter what they are, we just need to make sure when we multiply them that we are adding the value of the exponents. Okay. All right, let's try, whoa, I lost my track here. Here we go. Okay, let's try this next one. Find 3 times 10 to the negative fifth power plus times 5 times 10 to the negative second power. Write your answer in scientific notation. Okay, so I'm going to start just by writing my problem. 3 times 10 to the negative fifth power times 5 times 10 to the negative second power. Okay, I'm going to do commutative property here. I'm going to flip-flop these two. Now I have 3 times 5 times 10 to the negative fifth times 10 to the negative second. Okay, 3 times 5 is 15. When I do 10 to the negative fifth times 10 to the negative second, I'm doing 10 to the negative 5 plus negative 2. Okay, so negative 5 plus negative 2 is negative 7. So I have 15 times 10 to the negative 7. Just like our last ones with addition and subtraction, our last step is your answer in scientific notation? So let's look at it. 15 times 10 to the negative 7 power. Nope, not scientific notation, because my first number isn't between 1 and 10. So I'm going to take my decimal, I'm going to move it one place over. And remember, if your number doesn't have a decimal, that means the decimal's at the end. All right, my number here is 1.5. I made my number smaller. That means my exponent is getting bigger. So instead of 10 to the negative 7th, it's now going to be 10 to the negative 6th. With negative numbers, the closer you get to 0, the bigger your value. All right, and let's take a look at division. When numbers in scientific notation are divided, only the number is divided. The exponents are subtracted. So division and multiplication are reciprocals. You can do, look at multiplication and division kind of in similar ways, similar except opposite. So instead of adding with our exponents, now we're subtracting with our exponents. we're taking these problems, we're basically chopping them into two different problems and then doing the division here and the division here and then putting it back together. All right, let's try this one. Find 1 5/10 times 10 to the negative 8 divided by 6 times 10 to the 7th. Write your answer in scientific notation. When we're dividing with decimals, we don't have to line up decimal places. It doesn't matter how many decimal places we have in our numbers. It doesn't have to be the same. That's why we don't have to line up these exponents and make them the same before we divide. It's only in addition and subtraction with decimals you line up the decimals. So only addition and subtraction with scientific notation do we have to make the exponents the same. All right, we're going to split our problems down the middle. All right, so now we're going to do 1 1/2 divided by 6. Top divided by bottom, just like with fractions. Top divided by bottom. So I'm going to do 1 1/2 on the inside, 6 on the outside. 6 does not go into 1 a whole number of times. So I'm going to put a 0. I'm going to put a decimal. 6 does go into 15. It goes in 2 times. 2 times 6 is 12. 15 minus 12 is 3. I add a 0. I bring it down. 6 goes into 35 times. 5 times 6 is 30. Okay, so I did the first part of my division problem, and I got 25 hundredths. Now I have to do my second part of my division problem. I'm subtracting here. So I'm doing 10 to the negative 8 minus 7. And if it helps, you can do boom, change to addition, boom, change the sign. It's like 10 to the negative 8th power plus negative 7. Negative 8 plus negative 7 is negative 15. This is going to be a very tiny decimal. All right, is my answer in scientific notation? No, my first number is not between 1 and 10. So I need to move my decimal to make a number between 1 and 10. So I'm going to move it this way. This time I'm moving it to the right. That's making my number bigger. When my first number gets bigger, my exponent on my power gets smaller. So instead of negative 15, it's going to be negative 16. I went one space to the right, so that is like multiplying or dividing by 10, depending on which way you're going. So I moved one place over. I need to change my exponent one place. If the first number gets bigger, the second number gets smaller. If the first number gets smaller, the second number gets bigger. All right, find the product or quotient. Write your answer in scientific notation. Go ahead and pause the video and try these on your own. Okay, let's check our answers. Okay, so for number 3, and really number 5 is the same way. For whatever reason, they didn't give us a second power of 10. So we don't have to worry about that part of it. For this number 3, I'm just going to change my parentheses. I'm going to use that associative property. And instead of putting it around the 8 and the 10 to the negative 5th, now I'm going to put it around the 6 and the 8. 6 times 8 is 48 times 10 to the negative 5th. That's not scientific notation because the first number is not between 1 and 10. So I need to move that decimal over. It's going to become 4.8. I made my first number smaller, so now my second number needs to get bigger. Instead of negative 5, it's going to be negative 4. Let's take a look at our next one. 7 times 10 squared times 3 times 10 to the 5th power. We're going to use commutative property here and change up the order. 7 times 3 times 10 squared times 10 to the 5th power. 7 times 3 is 21. 10 squared times 10 to the 5th power is like 10 to the 2 plus 5 power, so that's going to be 10 to the 7th. Is this scientific notation? No, my first number is not between 1 and 10. So I'm going to move my decimal over. My first number is getting smaller, 2.1. So my second number needs to get bigger. Now it's going to be 10 to the 8th. Okay, I'm going to erase this a little bit. There we go. Okay. Let's take a look at our next one. 9 and 2/10 times 10 to the 12th divided by 4.6. Okay, let's see. 9.2 times 10 to the 12th divided by 4.6. Okay. So if I divide it here, I have 9.2 divided by 4.6. Remember when we're dividing and our second number is a decimal, we need to move the decimal places over. Okay, I now have 92 divided by 46. All right, let's see. 92 divided by 46. All right, I believe that's going to go in twice exactly. Let's double check that. 6 times 2 is 12. 2 times 4 is 8. Plus 1 is 9. Okay, so that is going to be 2 times exactly. Okay, and then I'm not really dividing this by anything. If I wanted to write this 4.6 in scientific notation, I could write it times 10 to the 0 power, because 10 to the 0 power is 1. And 12 minus 0 is still 12. So I have 2, and then it's going to be times 10 to the 12th power. Is that scientific notation? Yes, the first number is in between 1 and 10. All right, let's take a look at our next one. 1 and 5/10 times 10 to the negative 3rd divided by 7 and 5/10 times 10 to the 2nd. All right, let's write the problem out. 1.5 times 10 to the negative 3rd divided by 7.5 times 10 to the 2nd power. Okay, let's split our division problems here. 1.5 divided by 7.5. My second number is a decimal. I'm going to need to get rid of that decimal place. So now I'm doing 15 divided by 75. 15 is on top, so it goes on the inside. 15 divided by 75. 75 does not go into 1 or 15 a whole number of times. So I'm going to need to add a decimal and a 0 and a 0 and a decimal. All right, 75 does go into 150. It goes in 2 times. Exactly, 2 times 75 is 150. So for my first part of my answer, it's going to be 2/10 times. All right, and then over here, 10 to the negative 3rd minus 2nd power. Negative 3 minus 2, I could do boom, change to addition, boom, change the sign. Negative 3 plus negative 2 is negative 5. So I have 2/10 times 10 to the negative 5th power. Okay, is this scientific notation? No, my first number is not between 1 and 10. So I'm going to move this over. My first number is getting bigger. It's going to become 2 times. And because my first number got bigger, my exponent's going to get smaller. 10 to the negative 6. With negative numbers, the farther away from 0 it is, the lower the value. All right, let's take a look at a story problem. All right, how many times greater is the diameter of the sun than the diameter of the earth? When a story problem asks how many times greater, times makes it sound like multiplication, but how many times is division. If I want to know how many times something is, I have to divide to figure out how many times it goes into that thing. Okay, so we need to divide. We have to take the diameter of the sun, and we have to divide by the diameter of the earth. Now, I don't have them both in scientific notation. I have one in standard form. I have one in scientific notation. They need to be in the same form. It doesn't really matter. I'm going to change my sun into scientific notation, since that's the skill we're practicing, operating with scientific notation. So if I put my decimal here and I count 1, 2, 3, 4, 5, 6, I'm moving over 6 spaces. Okay, so then my scientific notation would be 1.4 times 10 to the 6th power. All right, so I'm going to take this over here. 1 4/10 times 10 to the 6th power divided by 1 28/100 times 10 to the 4th power. All right. So now we need to divide. I've got 2 decimals on this number. My second number needs to be in a whole number when I divide. So 1, 2 places over, I'm going to need a placeholder 0 here. 1, 2 places over. So I now have 140 divided by 128. So let's see, 140 divided by 128. Well, 128 goes into 140 one time. 1 times 128 is 128. All right, let's see. If I do 0 minus 8, it's going to take me into the negative, so I'm going to borrow. This will be a 3. This will be a 10. 10 minus 8 is 2. 3 minus 2 is 1. So I have 12. Now, I can't do a mixed number here because I'm working with scientific notation for my answer. So I've got to add a decimal and a 0 and a decimal here. Bring this down and keep on dividing. 128 does not go into 120 a whole number of times, so I'm going to add a 0 and another 0 and bring this down. Okay, 128 into 1,200. I'm going to guess 9 times. Let's see how close that gets me. 128 times 9. 8 times 9 is 72. 9 times 2 is 18, plus 7 is going to be 25. 9 times 1 is 9, plus 2 is 11. Okay, so I have 1,152. All right. Okay, so I am now going to subtract. 0 minus 2 takes me to the negatives. I don't have anything to borrow here. So I'm going to borrow from 20. I'm going to make that 19, and then I'll make this one a 10. Okay, 10 minus 2 is 8. 9 minus 5 is 4. 1 minus 1 is 1. 1 minus 1 is 0. 1 minus 1 is 0. So I have 48. Didn't really need to put those zeros in there. Okay, still not done. Ooh, I forgot to write my 9 down. Okay, that went in 9 times. I need another 0. All right. Okay, so let's see. 128 into 480. Let's see, if it was 120 into 480, it would go in 3 times exactly. So I'm going to do 2. All right, so I'm going to have to do that over here. 128 times, oh, no, I'm going to do 3. 120 times 4 would be 480. So I'm going to do times 3. Okay, 24. 3 times 2 is 6, plus 2 is 8. 3 times 1 is 3. So I have 384. All right, and let's see. 0 minus 4 takes us to the negative. We're going to borrow from 8. We're going to make it 7. This is going to be 10. 10 minus 4 is 6. 7 minus 8 takes me to the negative. So this is going to be a 3 and 17. 17 minus 8 is going to be 9. 3 minus 3 is 0. So I have 96. Okay. So I think at this point, for time's sake, I'm going to pause here. And I'm going to finish up my answer. So we're going to just round to the nearest. We'll round to the nearest hundredth. So that's going to be approximately 1.09 times 10. And then let's see, 6 minus 4 gives me 10 to the 2nd power. And then let's see, story problems need a label. I'm going to write times greater. So if you have a problem like this where it's really dividing a long way, we did 3 decimals and it didn't seem to be finishing, then we can round it to the nearest hundredth. All right, let's take a look at this next one. How many more kilometers is the radius of the sun than the radius of the earth? Write your answer in standard form. Okay, go ahead and pause the video and try this one. Okay, so let's go ahead and check our answers. So radius is half of the diameter. They're asking for an answer in standard form, so I'm going to go ahead and operate with my numbers in standard form. So originally my diameter was, for the sun, 1,400,000. Oh my goodness. Crazy things going on with my pen here. Okay, 1,400,000. So if I take that and I divide by 2, my radius is going to be 700,000. Okay, and then let's see. Earth was 1.28 times 10 to the 4th. Okay, let's make that standard form before we divide by 2. So moving my decimal 4 places over 1.28. This is positive, so my number's getting bigger. 1, 2, 3, 4. So that number is 112,800. That's the diameter. We've got to divide it by 2. That's going to give us 6,400. Okay. How many more means we are subtracting? All right, so we have 700,000 for the radius of the sun. We have 6,400 for our radius for the earth. Let's do some subtraction. 0 minus 0, 0. 0 minus 0, 0. 0 minus 4 takes me into the negatives. Can't borrow here, can't borrow here. So I'm going to borrow from 700. I'm going to make that 699 and make this one a 10. Okay, 10 minus 4 is 6. 9 minus 6 is 3. Then I'm going to bring down my 9, and I'm going to bring down my 6. 693,600 kilometers.